Welcome everyone, I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 2563, which is count the number of fair pairs. Let's see the problem statement. Given a zero index integer array nums of size n and two integers lower and upper, return the number of fair pairs. A pair ij is fair if I and j is within the range of 0 to n and lower is nums I plus nums j is in the range of lower and upper, and the constraints are the length of the given nums array will be up to 10 to the power 5, and each of the element will be from negative 10 to the power 9 to positive 10 to the power 9, and the lower and upper value will be the same from negative 10 to the power 9 to positive 10 to the power 9. So to solve this problem, let me discuss the algorithm with you. First, we need to sort all the elements. Then we can find the minimum value and maximum value to which will be added with our current value to make the sum within this range. Okay, just by subtracting the current value from lower, we will get the minimum, and subtracting the current value from upper, we can get the maximum value, which we need to add with our value so that we can be in the range of lower and upper. And we previously sort all the elements because so that we can find the minimum value and maximum value in log n time complexity, and to find the element we can use the inbuilt function lower bound and upper bound, and then we will add the number of element we like number of pairs that we can make using our current element. Okay, so let's start. First, I am using LL is equal to long long so that I do not need to write the long long again and again. Then let's first sort all the elements. Sort nums dot begin to nums dot end. That's it. And also declaring the answer. So LL answer, because the latent type is long long, so answer will be 0 initially. Now let's traverse from 0 to the size of the length. So for int I equal to 0, I less than nums dot size I plus plus. For each of the element, first we need to find the max and min like elements which we need to add to be in the range of lower and upper. So let's low is equal to lower minus current value is nums of I, and same as the high value, high will be upper minus nums I. This is the range. Okay, that we need to minimum we need to add a low value with our current element to get in the range, and maximum we can add high value. Okay, up to high value. So now we need to find the index of the low and high value. Find that. First we need to check like we need for low value we need lower bound, because let's say there are x elements which have the same value. So we need to consider all the the pairs with all the elements. So we need the first element, because the array is already sorted, so we need the first element which have the first value. Like if there are 10 elements with the same value, we need the first one. To get that, we will use lower bound. So auto lower bound, let's say mn. So lower bound function is lower bound, and we need to find from nums dot begin to nums dot end, and we are finding the low value. That's it. Now we always find the values or another, because one element is our current value, and to make a pair we will find another element which will be left side of the current index value. Okay, why left side? Because the elements could be right side also, but we do not consider the right side, which is because whenever we will go, like the pointer or the traverse will go in the right side, then for that element this current element will be the left side of the that element, so then we will consider that pair. So now for the current element we will always consider the left side elements. To get the left side element we need to check another if condition that if mn is not mn, because mn is a like a reference, so we need to subtract the nums dot begin from that to get the index value. If this value is greater or equal to I, because we can't take the I value also, because the ij can't be the same, so we are adding greater or equal to of I. If it is true, then we will continue. Okay, now if it is false, that means the index is less than the I. So let's take the index L equal to mn minus nums dot begin. That's it. Now for the high value, so for high value, if there are multiple elements with the same value, we need the last one, because we need to consider all the elements and it is a low and high value. So for low we will consider the first element, and for high we will consider the last element. To get the last element we will use upper bound, but there is one catch, because the upper bound always give greater value, the lower bound gives less equal value, but the upper bound gives greater value. So we need to subtract 1 from that index also. So keep in mind that. So auto mx, let's say, is upper bound of nums dot begin to nums dot end, and we are finding high value. Okay, now we need to check. Let's say int r equal to, the value will be mx minus nums dot begin to get that index, and minus 1 to get the actual index, which are like greater equal to of that value. Like we need to find the, like, high is the maximum value, so we will always find less equal value, and we need, if there are multiple elements, we are considering the last one, so we need to minus 1, because this upper one will give at least plus 1 value of this high. Okay, we need to minus 1 the index, but there is one catch, because the maximum index we can go is I minus 1, because I already told you that we are finding all elements that are left side of the current value. So to get that value, we will use the minimum function. Minimum of I minus 1 is the max index that we can reach, and int of this value. Okay, because this could be the high value maximum. It can be the left side of the current element or the right side, but we can't go right side, so we will take the minimum of I minus 1 and this. Okay, now answer plus equal to, the all the number of elements will make one pair, so the total number of elements will be the number of pairs. So to get the total number of elements will be r minus l plus 1, because both are inclusive. The index l and r both are inclusive, so we need to add 1. That's it. Now at the for loop we need to return the answer. So let's see, will it work or not. It is accepted. Let's submit it. So it is accepted. Let me discuss the time and space complexities of this algorithm. To sort this given nums array, it is taking big O of n log n time, where n is the length of nums. And for all the elements, we are traversing for all the elements, and this lower bound upper bound functions, because as it is a sorted array, this lower bound and upper bound functions takes log of n time to find. So it is taking log of n time and it is taking log of n time. So both are in total 2 into log of n time. But we can exclude the constant one. So we can assume that this inner for loop is taking big O of log n time, and we are performing it for all the elements. So overall time complexity for this overall for loop is big O of n into log n, and this is also taking n log n. So overall time complexity for this whole algorithm is big O of n log n. And in case of space complexity, we are not creating any array or list which is depending on the length of the given array. We are just using some variables. So the overall space complexity is big O of constant, or you can say big O of 1. So thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.